Picking up where we left off, after that last example, we can now define the derivative of a function f of x at x equals a. So a lot going on here, and arrows and kind of notes and things like that, and then the notation. So here we go. So you notice, for one, just ignore what's on the left here. I'll explain that in a moment. Right there, that is exactly the formula we used in the previous example. Okay, we've got the limit as h approaches 0, f of a plus h minus f of a. In our example a moment ago, the a was 3. We were doing it at 3. But we'll say in general, a plus h and f of a plus h minus f of a. And notice we just put it over h. In general, you might think, well, how did we start that last example? It was 3 plus h minus 3, right? But whatever that number is, that's always going to cancel out, and you're always simply going to get h in the denominator. So we don't need to write, maybe in the more general style, a plus h minus a. Well, that's always going to simplify down to just h, so we don't need all that. We can just say the h. Okay. So the derivative, the formula for the derivative, is simply exactly what we just did a moment ago. Now, here's the thing. Whenever you learn something new, a new concept in math, there is always a new notation to write it. Okay, so we want an easy way to refer to this formula, or like to the answer of a derivative question. So here's what people agreed on hundreds of years ago. They said, this thing is so big, it's gonna change the world. We need something that's super simple, and we'd like a notation that is very close to f of a, right? Just like a function notation, because this thing is gonna be so big. We want it to be very close to the original function notation. So people, over a period of time, eventually decided on this. So that's f of a, but right there, there's what we call a little prime, like a little apostrophe. Okay, and you read it literally as f prime of a, f prime of a, and it means the derivative of the function f of x at a. Okay. Now, when we say the derivative of f of x at x equals a, that's the mathematical notation for it, but what does it represent? And so I've got three things, three different but all true interpretations of what the derivative could mean. So in the last example, we saw the first one, the instantaneous rate of change of f of x at x equals a. How fast is the function changing at that moment? Okay. That's one way of interpreting it, or one way a question could be asked. Find the instantaneous rate of change. They mean to find the derivative using that formula right there. Okay, you might also hear something very similar, find the instantaneous velocity. Right. Well, we used that in the last example as well. Especially if it's an object that's in motion, you're going to hear instantaneous velocity being used, and that's a big application and something that we see quite a bit here as we're first learning about this. And finally, you might just hear it referred to as the slope of the tangent line. That's what it represents graphically. Find the slope of the tangent line of this function at this x value. Well, they mean find the derivative there. Okay. Let's see this in action, and we'll practice this notation. Obviously, we're going to practice the formula more too. That'll be big. We're going to go with this example right here. Now notice what they're asking. Find the equation of the tangent line. Okay, so the derivative is the slope of the tangent line. So we're going to start by finding the slope of the tangent line of this function at x equals 1. But then we're going to go a step beyond, and we're going to get the equation of that tangent line. Okay. But it all starts with the slope. So let's see here. F of x equals 2x to the third plus 5 at x equals 1. So let's go ahead and set it up. So I'm basing this just on that derivative formula, and I'm just going to put a 1 in wherever there was an a, right? So in the formula, it was f prime of a. Well, I'm going to put a 1 there. F prime of 1 equals the limit as h approaches 0. Now, this part never changes. It's always limit as h approaches 0. That will never change, h approaching 0. And then we're going to fill in the a couple more times. F of 1 plus h minus f of 1 all over h. Okay. Now we're going to apply both of these in the numerator to this function right here. So I'll show you that. We're still going to write f prime of 1 here on the left. And we're going to say equals, and we're just going to repeat limit as h approaches 0. Okay. And then right there, f of 1 plus h. Okay, well, that means the 1 plus h goes in for the x. So it's 2 times 1 plus h to the third plus 5. And I like to put a big bracket around that. Okay, minus, and then f of 1, and, well, I'm not sure why I did these brackets at this point, but that's okay. No, it's good, because this minus sign needs to distribute, right? Yeah, we got to have that. We got to have that. Okay. 2 times 1 to the third plus 5. Okay, that works. So we've got f of 1 plus h minus f of 1 all over h. Let's keep simplifying. And now here's what I did. I went ahead and just multiplied out this 1 plus h to the third in one step. Now that you might not remember how to do that. You would have learned how to do this sort of thing back in an algebra class. It's called the binomial theorem. Or you might remember Pascal's triangle. But if you don't remember that, no big deal. Just multiply this out 3 times. I wanted to spare us that algebra here, just for just so we can focus more on what's happening with the derivative. Okay, but there it is. If you multiply that out 3 times, you'll get 1 plus 3h plus 3h squared plus h to the third. Of course, we got to multiply that too. And we're still adding this 5 on the end. And I just went ahead and did this calculation. Well, 2 times 1 plus 5 is going to be 7, so we got to subtract 7. Okay. And I still have the f prime 1 out here in the front. Let's continue on. I've got to grab another page. Okay. Just continuing to simplify. Nothing fancy here. Okay. F prime of 1 equals the limit as h goes to 0. H approaches 0. We're just copying this still. And now up here, let's distribute the 2. And I went ahead and did the 5 minus 7. So we've got 2 plus 6h plus 6h squared plus 2h to the third minus 2, and it's all over h. Okay, and still working with the algebra, we notice 2 minus 2 cancels out. And after the 2's cancel, the remaining parts all have an h. We can factor an h out there. And we'd be left with 6 plus 6h plus 2h squared all over h. Of course, this stuff gets repeated again. Okay. And, from there we can cancel the h's, obviously. And it's all kind of working down. So f prime 1 equals the limit as h approaches 0, 6 plus 6h plus 2h squared. And at this point now we can finally plug in the 0 safely. And, well, that times 0 and that times 0, we're just going to get 6. F prime of 1 equals 6. Just kind of ignore that, what I've got right there for the moment. That is the slope of the tangent line. We got the derivative value at 1. So the tangent line at this function at 1, we didn't graph it or look at it, but the tangent line just grazing by the function, going in the same direction, just skimming by it, just hitting it at that one moment, the slope of that line would be 6. Okay, but of course that's not what they asked for. They wanted the equation of the tangent line. Well, if we have the slope, we've done most of the work at this point. We also need to know a point that's on the tangent line, and so we're going to use the point at 1. Now it turns out the point there is 1, 7. How do we know that? We've actually done the work already. It was actually way back here. When we figured out f of 1, well, that's the x value and the y value. And f of 1 turned out to be 7. All right, we plug 1 in, right? So we know the slope of the tangent line is 6, and we know that it passes through the point at 1, 7. And so we can use our point slope form. You would have done this in our review. Y minus y1 equals m times x minus x1. Hey, we got our slope m, we got our x1, our y1. Let's plug all those in. Y minus 7 equals 6 times x minus 1. Simplify that. Let's get a y equals mx plus b form, right? Y equals 6x plus 1 when we're done. There's the equation of the tangent line. We did it. Okay, I think what I'll do after doing these videos, I'm going to do a short Desmos video graphing this stuff and just kind of highlighting Desmos again. Not a bad idea, but you got to see this in a graph because it's so awesome. Okay. Let's stop this video here. That was a good example. See you in the next one.